Hello, everybody. My name is Kai Ganji. I'm a senior at Stuyvesant High School in New York City, and today I'll be presenting my paper titled AniVid, a novel anime video dataset with applications in animation. My motivation for this project stemmed from the issue of Japanese animators being overworked and underpaid, as episodes require an average of approximately 3,000 drawings total, which is quite laborious. As a result, researchers have been developing AI-based tools that can automate certain steps of the animation production process, such as sketch editing, character generation, and line art colorization. I propose the use of the first order motion model, abbreviated as FOMM, to automatically animate a source image using the motions extracted from a driving video. Thus, my contributions can be summarized as follows. First, I developed a semi-automatic data collection pipeline, which is used to construct AniVid, a novel anime video dataset. And using this, in the process of constructing AniVid, I trained a YOLO v5 anime face detection model that outperforms other current models for this task. Lastly, I trained FOMM on AniVid to automatically animate still images of anime characters. Just to provide a brief overview of the dataset, there are 34,221 videos compiled from 19 different anime series. The average length of each video is 2.74 seconds, average frame rate of 23 FPS, and they come in MPEG encodings and H.264 containers. And just for reference, here are two videos from the AniVid dataset. And this diagram summarizes my dataset collection pipeline. So I compiled 90 different shows from an anime streaming site, and I download these shows using the anime-dl command line program. Upon downloading them, I took these full-length episodes and split them into shorter clips based on the detected shot boundaries from the Transnet V2 model. On the side, I trained a YOLO v5x model on the Pixiv image dataset, and I evaluated this model on these shorter video clips. And any video clips with faces detected were kept, and video clips without faces detected were eliminated from the dataset. Lastly, I performed the task of motion detection on these clips using the DVR scan model. Any clips that did not have any detected motion were removed from the dataset as they would not be suitable training data for the first order motion model. As I said before, I performed the experiment of anime face detection using the YOLO v5 model. It was trained on a Pixiv image dataset of 6,173 images. And as you can see, these are the metrics and results, where MAP is at 0.5 is the mean average precision at IOU threshold of 0.5, and MAP at 0.5, 0.05, 0.95 is the mean average precision at an IOU threshold of 0.5 with a step size of 0.05 up to IOU threshold of 0.95. The second experiment was the first order motion model, which was trained on AniVid, which extracts the movements from a driving video and projects them onto a source image. So here's an example of a qualitative results. Here's a driving video. And these are the results after extracting the motions from the driving video onto the source image. And here are some quantitative results. So just to preface, the first order motion model was trained on 5 different datasets when released to the public: Bear, Fashion, UVA, Nemo, Taichi, and Voxel. And I evaluated the performance of each of these 5 separate trained models onto my AniVid dataset. So to evaluate the performance of the first order motion model, I first performed the task of video reconstruction on my test set. And this is done by implementing FOMM on the first frame of each video, using the video itself as the driving video. I then compare each frame from the ground truth video to the generated video using 6 image similarity metrics as shown here. As you can see, this performance when trained and evaluated on AniVid outperforms the other trained iterations of this model when evaluated on AniVid as well. In conclusion, AniVid has numerous other applications for tasks such as frame interpolation and action recognition. I define the novel task of applying the first order motion model to anime specifically. And in future work, I hope to develop the domain adaptation framework, implementing the use of human data. I hope to incorporate live video footage and use this technology for virtual YouTubers as well. Thank you for watching.